Wow, cool guitar. Thanks, dude. Did you ever wonder how one of these things work? Well, let me tell you. At the heart of an electric guitar's sound are the pickups. Pickups consist of magnets wrapped in coils of wire. The strings themselves are made of ferrous metal and will interact with the magnetic fields in the pickups. When you pluck a string, it vibrates, which causes the magnetic field to move, and from electromagnetic induction, creates a small electrical current in the coil. This current is then sent to the guitar's output jack, where a cable is connected to send the signal to the amplifier. There are various types of pickups, each with a unique sound. Single-coil pickups are known for their bright, crisp tones, while humbuckers offer a warmer, fuller sound. They are called humbuckers because they were developed to remove the hum that single-coil pickups may produce from environmental interference. What about the amplifier? Well, now that we have an electrical signal, it's time to make it loud. An amplifier boosts the weak electrical signal from the guitar, making it strong enough to drive a speaker and produce sound. It also shapes the tone, allowing for a wide range of sounds, from clean and smooth to distorted and gritty. Amplifiers come in various types, including tube amps, known for their warm, natural sound, solid-state amps, which are reliable, versatile, and light, and modeling amps, which can emulate the sound of different amp types and effects. We'll have a look at how a tube amp works today. The small signal is sent from the guitar to the amplifier by a cable. Vacuum tubes, also known as valves, are electrical devices called a triode, and they are made up of various components that are in a vacuum inside an airtight glass container. The components inside of the glass tube are the two electrodes, negatively charged cathode and positively charged anode, a heating element for the cathode, and the control grid. When the cathode is heated up, it emits electrons to the positively charged anode. The electron flow from the cathode to the anode is controlled by applying a voltage at the control grid. Applying a small AC voltage signal from the guitar to the control grid manipulates the electron flow through the cathode to the anode such that it copies the signal and also amplifies it. Amps have different stages where the signal is amplified. A typical configuration will consist of a couple of preamp stages and one or more power amp stages. Some tubes have more than one triode inside of the same tube, so it can be used for two amp stages. There are several electrical components also inside the amplifier. The power transformer increases the supply voltage from the electrical outlet to drive the amp stages and supply smaller voltages to the heating elements in the vacuum tubes and the rectifier. A rectifier is a device that converts the alternating current to direct current. Capacitors and resistors are used to smooth out the pulsating DC voltage from the rectifier. There is also an output transformer that steps the amp's voltage down and steps the current up to drive the speaker. The amplified guitar signal creates a changing magnetic field in the transformer's primary winding that induces the voltage in the secondary winding. The induced voltage signal also matches the guitar's. The current from the secondary winding flows through a coil inside of the speaker and creates a magnetic field that interacts with the speaker's permanent magnetic field. This causes the speaker's cone to move and create pressure waves in the air that our ears perceive as sound. Cool guitar.